Hi guys, welcome back to Math 115. So this is the first time we're starting an actual new lesson, new material since we've gone online. Up until now, we've only had reviews and tests. So here's a little outline of the plan moving forward. This week, we're going to do Chapter 7. We're going to skip Chapter 8, and next week, we're going to be doing Chapter 9. Both of these chapters have only 3 sections. Actually, Chapter 7 originally had 4, but I'm cutting one out because I just thought we'd spend extra time reviewing last week, so we lost a day. But no big deal. We'll have plenty of time to cover things that we really need to. The section we're cutting out is just about the proportions for hypothesis testing. Kind of like the last section of 6 was like the same ideas, but we're applying it to proportions. But it's okay. We'll just forget about that. Now, right now, this first video, what I'm planning to do is just go over the first couple pages where we're looking at just the definitions from 7.1. This is the only video for this chapter where I'll really have to do this. Afterwards, for 7.2 and 7.3, we're more focused on problems. There's very minimal new definitions. Okay, so let's just jump into it. Let's get started. This is chapter 7.1, Introduction to Hypothesis Testing. And here's what you need to know. First of all, what is a statistical hypothesis? A statistical hypothesis is a statement about a population parameter. Just kind of remember with me some of these words, what they meant. Population is when we're talking about every data point in the entire population, right? Everything. And parameter is the word that we use when we're having statistics or we're looking at numbers for the entire population. That's like the equivalent would be sample statistic if we're looking at only a portion of the population. Okay, so a hypothesis is we're making some guess about or some estimate about what that population parameter is. And when we're talking about parameter, typically we're only concerned with the mean, right? That's what this whole class is pretty much focused entirely on. And so when we say population parameter, we're really making a hypothesis about the mu value, mu. Now there are 2 types of hypotheses, H0 and HA. H0, we call it H0 because, I don't know, in math we say 0 not sometimes like that. And we call this the null hypothesis. Null is another word for 0, I guess, right? So null hypothesis, what it is it's the part of the hypothesis that includes equality. So we're making a statement about the parameter. It could be where mu is equal to something, mu is less than or equal to something, or mu is greater than or equal to something. Now the alternative hypothesis to that, HA, that's the complement of the null hypothesis. So if the original null hypothesis included equal sign, mu is equal to some number, its complement would be not equal to that number. If the original H0 is less than or equal to something, its complement would be strictly greater than. If the original H0 is greater than or equal to, its complement is less than something. One thing that you should note, and this is true for complements in general, if you have the original value being true, then its complement is going to be false, and vice versa. If the original hypothesis is false, then its complement is going to be true. Okay, let's take a step back now. We're going to look at this right side of the page and just kind of take an overall picture of what we've been doing, what's been happening. If you recall back to the very beginning of the class, we talked about 2 types of statistics, descriptive and inferential. Descriptive was just when we're describing the data we already have, and we're maybe like displaying it so that it's easy to view and kind of see what's happening. And we have inferential. Inferential is when you try to draw conclusions about the bigger picture of data using only a small sample of it, right? Now, in our previous chapter 6, we were doing estimation. That's when we had the confidence intervals, right? That was a type of inferential statistics. We're looking at trying to find like some interval where the true population parameter is going to be using only a sample. Now in chapter 7, we're continuing to do inferential statistics in a little bit different way, although it's kind of related, but a little bit different. Now what we're looking at is we have some decision that we want to make about whether our hypothesis is going to be true or not. So typically we're going to estimate, okay, is our mean going to be equal to some value, less than or equal to some value, greater than or equal to some value, and we want to see if we're correct or not. And finally, for the last type of inferential statistic that we'll look at is predictions. We'll look at this in the next chapter, so this will be next week. Okay, let's come back to today. What are we doing? what's the big idea today? We're doing hypothesis testing. In hypothesis testing, what we're doing is we're deciding if we should reject or fail to reject H naught. Now, be careful. We say fail to reject for a reason. We actually do not mean accept. We just mean that we reject or we do not reject. But that's a little different from accepting. I'll get more into that when we look at this note on the right, but let's just leave that for now. Let's talk about the two types of errors that you could make when you're trying to decide if you should reject or fail to reject. Now, every time we do these hypothesis tests, it's always in terms of the original H naught. There are two types of errors that could occur. Type 1 error is when I reject H naught even though it's actually true. Obviously, that's an error, right? You reject something, but it's true, then you made a mistake in your deciding if you should reject or not. And the type 2 error is not rejecting H naught when in fact it's false. Now, the next term, level of significance, this is focusing in on type 1 error. It's the maximum allowable probability when we decide to reject H naught or not. And typically it's going to be less than 0.1. So in other words, 10% or less. A lot of times it's going to be 5% or even just 1%. And the idea is this: if you have some hypothesis H naught, if it's unlikely to happen, then we're going to reject that hypothesis. But unlikely, that word unlikely is kind of arbitrary, right? So we want to be more specific and decide, well, how much are we willing to allow? Like if it's 10%, if it's going to happen with 10% likelihood, then is that enough to reject? Or would you want to go down to 5% or 1%? Okay, one more thing about when we reject or fail to reject. This is what I was kind of alluding to earlier, but we should be very careful. When we reject H naught, we can definitively make some decision about the claim. Now, the claim is going to be either the original H naught, or sometimes the claim could actually be the alternative hypothesis, HA. But in any case, when we reject, that's when we can make some definitive answer. However, if we fail to reject, we actually don't really know anything. We don't know for sure if we can reject or accept the claim. We're just failing to reject. I know this sounds kind of weird, right? And like honestly, to me, it's a little weird too. Like it's much more simple, and for the most part, you just want to kind of think of if you're failing to reject, then it's kind of the same as accepting. But there's like in statistics, if you talk to a statistician, they're really particular about the language here. It's kind of like when you go to a court of law. If you go to a court of law, someone's presumed innocent, right? And if you prove they're guilty, then they're guilty. But if you do not prove they're guilty, that doesn't mean they aren't guilty. They might actually be guilty, but you just haven't proven it, right? So you fail to prove guilt. It's kind of the same concept here. We fail to reject, but that doesn't mean it shouldn't be rejected. I was actually listening to this podcast about this serial killer, and he went to trial and like wasn't convicted for several times. And so like even though he was guilty, they didn't convict him the first time. That doesn't mean that he was innocent, but it just means that they failed to convict. So they failed to reject his claim of innocence. Okay, so so one more note about that. If you want to look at the table on page 356, I think it has a nice summary for this fact that we just talked about. Okay, on to the second page. This one should be a little shorter. The test statistic. So let me actually relate this back. If you look back to the original page, statistical hypothesis, that was about the population, right? And we're trying to draw a conclusion about the population parameter. What we use is the estimate, the test statistic. That's just X bar, using that to estimate mu, basically. In fact, over here, I should probably type in mu here. Let me do that right now. There you go. So what do we mean by the test statistic? We're just estimating the statistical hypothesis, which is this is about u. Yeah, it's about mu. The test statistic, for us, we're looking at X bar. That's the mean for the sample, right? And remember, the hypothesis is about the population, so the mu value. Now, look, all this stuff is actually going to look very familiar. We've pretty much done all the same kind of stuff when we did the probability chapters, and even in chapter 6, very similar stuff. We're not using any new calculator functions really. It's just a matter of how we're interpreting things. The standardized test statistic, that this next part, that's just the z-score or the t-x score, the t-score, z-score. This is really the same thing that we've seen in the previous chapters. Now the p-value, this p-value is the probability of a particular test statistic occurring, assuming h naught is true. And this is what we're gonna compare to that alpha we talked about earlier. But this p-value, also nothing really new actually. This is just the probability associated with a particular z-value. Okay, now there are 3 types of tests that we can use, and which test we're going to use is going to depend on what our original h naught is. So if h naught is greater than or equal to, we want the right-hand test. If it's, I'm sorry, I got the other way around. Well, if it's h naught is greater than or equal to, we want to use the left-tailed test. The reason for that is because the alternative hypothesis is the one that includes less than that value, right? So when we're deciding which tail test to look at, we actually look at the alternative hypothesis, the the complement of the original h naught. Okay, so if my original h naught hypothesis is greater than or equal to, that makes my alternative hypothesis less than, and so I'm going to use the left tail test. Left tail test is just corresponding to this picture. Remember, I have my normal curve, right? I'm looking at the tail on the left side of my z. Okay, h naught being less than or equal to means that HA, alternative hypothesis, is greater. That's when I'm going to use this right-handed test, right tail test. Oh, I just realized, I'm not sure who made these. I kind of stole these pictures. These h naughts are actually a little deceiving. This should actually say mu greater than or equal to k. This one should actually say less than or equal to k here. But I'm not able to edit these, so we'll just have to refer to this table on the top for us to know what it really is. Okay, now for the two-tailed test. The two-tailed test is when my original h naught, this one is accurate, when mu is equal to some value, and then the alternative hypothesis would be not equal. Not equal meaning it could be not equal on either side. So that's where we get the two-tailed test. Okay, guys, and that's pretty much all the theory technically for this first section. This first section is really just focused on setting up the questions. I'm gonna cut the video off here, and then we're gonna talk about how to do the actual problems now. I know it's a lot. I've been talking kind of a lot, which I don't like to normally do, but I think there's no way around it for this first part. And even though it's a lot, it seems like there's a lot of information coming at you. It's gonna start to come together, I think, as we look at the actual problems and how to solve them. And that will come in the next video, and when we start looking at this next page. Okay, guys, that's it for now. So I'll see you in a little bit.